There are three non-obvious inflection points we highlight. If you can't recall them afterward, re-listen. They anchor the whole strategy. Welcome to AI on AI, the show where we dissect how artificial intelligence actually moves through the world, from lab breakthroughs to the messy reality of deployment and the economics underneath. Today, we're diving deep into Microsoft Research's AI Diffusion Report, a sweeping analysis of where AI is most used, developed, and built, and crucially, why diffusion, not just invention, determines societal value. With 9 experts ready to challenge each other and synthesize strategy across the 3 forces of diffusion: frontier builders, infrastructure builders, and users.
Thanks for having me. To set the table, the report operationalizes diffusion through 3 complementary indices: the Frontier Index, who's pushing model performance, the Infrastructure Index, where compute, power, and connectivity live, and the Diffusion Index, who's actually using AI in the real world. And methodologically, we blended performance across coding, SciCode and LiveCode Bench, knowledge, MMLU Pro and HLE, long context reasoning, AALCR, instruction following, IF Bench, and graduate-level science Q&A, GPQA Diamond, then mapped countries by their months to frontier metric, while infrastructure capacity relied on IEA gigawatt estimates and data center locations, Oxford SSRN work, and diffusion was estimated via aggregated and anonymized telemetry from over 1 billion Windows devices, corrected for non-Windows market share and mobile versus desktop distribution to produce a population-normalized usage proxy over time.
That triangulation matters because the engineering reality behind those indices, how models are trained, where inference runs, and whether latency and bandwidth keep people engaged, determines adoption. For example, if an assistant's 95th percentile latency creeps past about 2 seconds, you typically see session drop-offs, and with LLMs, inference is GPU-bound with token-level streaming, so proximity to compute and smart routing, think regional shards, speculative decoding, and prompt caching can shave hundreds of milliseconds, which, oddly enough, translates directly into user trust and task completion rates in real deployments.
Staying on proximity, we quantify the latency curve using round-trip time plus token generation throughput, a 50 to 70 milliseconds lower round trip achieved by placing regional inference clusters and tightening peering with local ISPs, has shown double-digit increases in daily active usage for productivity apps. The architecture pattern is regional points of presence with CDN edge caches for retrieval corpora, dedicated low-latency links to GPU clusters, aggressive prompt result caching, and policy-aware routing for data residency. Layer on micro-sharding of high-traffic models, and you keep tail latency predictable, which is the invisible backbone of diffusion.
And when that backbone exists, diffusion turns into economic multipliers. The report's north-south adoption gap, roughly double in the global north, tracks closely with GDP and digital foundations, but the outliers like Singapore, UAE, Norway, and Ireland show that policy coordination and skills can compress time to value even without frontier labs. In practice, we see sector returns in manufacturing quality, port logistics, and financial compliance when AI is fused into existing workflows. Companies report cycle time reductions and error rate drops that compound over quarters, not just demo day moments.
To bring it down to ground, I tend to work where reliability is brittle. The Global South's constraints start with electricity. Intermittent power breaks everything from model endpoints to peripherals, so we build deployment stacks that assume brownouts. Solar-backed microgrids with battery storage for clinics and municipal offices, offline-capable clients with on-device distilled models for triage tasks, and asynchronous sync when connectivity returns. Where data localization is law, we do hybrid patterns: local inference for sensitive records and cloud for heavy workloads, which lets ministries comply without sacrificing capability.
The governance lens sits across all of that. Equity, inclusion, and safety aren't add-ons. The language barrier is a structural exclusion. Half the web's content is English, yet only about 5% of the world speaks it natively. Low-resource languages show adoption rates roughly 20% lower even after adjusting for GDP and internet, and model accuracy drops below 55% on some of them. Policy responses must therefore include electricity access goals, connectivity programs, digital and AI skills curricula, and incentives for content creation in local languages, plus workable cross-border compute frameworks that respect data protection without freezing innovation.
On language ecosystems, the core technical issue is data sparsity and tokenization mismatch. Many low-resource languages, Yoruba, Guarani, Hausa, have fewer web pages by orders of magnitude than peers with similar speaker bases, and byte-pair encoding optimized for English subwords fragments agglutinative and tonal languages, increasing the effective perplexity. Research agendas should prioritize community-led corpora, sentence-piece unigram tokenization tuned per language, morphological segmentation, and bilingual lexicon augmentation. In training, we leverage cross-lingual transfer by mixing multilingual pre-training with adapter layers and targeted low-rank adaptation LoRa, then validate on MMLU Pro X to ensure we're lifting reasoning, not just surface fluency.
I want to poke at the GDP correlation. A strong pattern, sure, but we risk mistaking correlation for destiny. Adoption may be bottlenecked less by lack of compute, and more by three overlooked frictions: payments, trust, and local workflows. If SMEs cannot pay for usage because mobile money rails are siloed from cloud subscriptions, or if the assistant doesn't speak the actual trade dialect at the market, usage stalls. I'd argue an alternative path. Mobile-first offline assistants with tiny local models plus SMS USSD front-ends and civic datasets owned by communities could out-diffuse big cloud in certain regions and might even be more resilient.
That's the element of surprise I was hoping for. Offline-first micro-assistants challenging cloud-centric diffusion. Before we unpack that, let's anchor on findings. The report shows AI as the fastest-spreading general-purpose technology in human history, over 1.2 billion users in under 3 years, yet nearly half of humanity still lacks electricity, connectivity, or the skills to participate. Frontier performance gaps are narrowing. China trails the U.S. by less than 6 months, and data center capacity is heavily concentrated, with the U.S. and China hosting about 86% of global compute, which creates both momentum and concentration risks.
On the frontier narrowing, our months to frontier metric is computed by taking each country's best performing model and mapping it to the date when an equivalent score sat on the global frontier. The compression from years to months indicates faster diffusion of research practices. Open weights like Llama catalyze community variance. Cost per token has dropped as inference optimizations propagate and training recipes are more standardized. But we still observed 7 countries dominating frontier-level models. So while the performance gap narrows, the locus of innovation remains compact, which has implications for compute governance and model supply chains.
Under the hood, that narrowing owes a lot to training and inference tricks, gradient checkpointing, distributed data parallel with zero-style optimizer partitioning, curriculum learning that mixes synthetic chain of thought, and, increasingly, retrieval-augmented generation, RAG pipelines that offload factuality from parametric memory to document stores. At inference, speculative decoding and early exit criteria reduce wasted compute, and quantization-aware training allows smaller footprints for edge models. The upshot is that even mid-market teams can achieve near-frontier capabilities for many tasks, provided they can access stable compute and curated data pipelines.
But we should talk energy and thermals. Data center growth is gated by power. GPU clusters draw dense loads, so designs are shifting to immersion cooling, waste heat repurposing into district heating where viable, and co-location near renewable sources with firming capacity. From a network standpoint, we overlay regional inference with peering at internet exchange points to cut traversal hops, and we cache embeddings and retrieve chunks at the edge. Pattern-of-life analyses inform autoscaling to flatten spikes. Done right, you can keep power usage effectiveness in check while expanding compute sovereignty outside the north.
Strategically, companies and governments can treat diffusion infrastructure like ports and highways, long-term assets that, once built, enable industry clusters. The report's lesson from South Korea versus the Philippines is instructive. Mastery and scaling of adopted technology beat invention alone. For boardrooms, the investment thesis is staged. Phase 1, connectivity and skills. Phase 2, data center partnerships or regional cloud placements. Phase 3, sector-specific AI capabilities in manufacturing, finance, health, and logistics. Returns come from throughput and quality gains. A manufacturer achieved near 30% cycle time reductions over 6 quarters by pairing a hybrid neural symbolic system with RAG against process manuals, for instance.
Taking that to deployment playbooks, we start with an AI readiness assessment: power reliability, bandwidth baselines, device mix, digital literacy. Then we choose patterns. 1. Cloud first with aggressive caching in markets with decent connectivity. 2. Hybrid with local inference gateways where data laws bite. 3. Edge first for rural clinics or schools using distilled 7B 13B class models, quantized to 4-bit for on-device. We accompany with skills modules: practical prompt engineering aligned to tasks, data stewardship, and failure mode drills. If the cluster's down, what's the offline fallback? This builds operational resilience rather than dependency fragility.
And from the product lens, diffusion is about trust and immediate utility. If a teacher or shop owner doesn't see value in a minute, they're gone. We design for low bandwidth contexts, progressive streaming responses that get to the point quickly, lightweight UI that works on a low-end Android device, and interaction in local languages with code switching. Features are workflow first. Templates for lesson plans aligned to local curricula, SME invoice reconciliation against tax rules, and government service explainers. We track adoption not by raw usage, but task completion and repeat usage, which tells you whether the assistant is actually doing a job.
On responsible usage, policy packages should mirror the report's building blocks: electricity, connectivity, skills, language, and build guardrails, risk assessments for AI in public services, clear data protection with transparent audit trails on RAG sources, content moderation aligned to community norms, and incentives for local corpus creation. Importantly, data localization should be nuance-based. Health and finance data localized, but generic inference allowed cross-border with transparency and redress mechanisms. Otherwise, we starve innovation while trying to protect it.
Let me add a concrete language pipeline. We start with community-sourced texts, education materials, radio transcripts, public documents, apply quality filters, and perform bilingual alignment. Then we train language-specific tokenizers and adapters on a multilingual base. For low-resource speech, we combine text with forced alignment from modest audio datasets to build speech-to-text and text-to-speech. We generate synthetic parallel data via back translation, but we constrain it with lexical lists and domain glossaries to preserve meaning. Evaluation uses MMLU ProX plus task-specific datasets, say agronomy Q&A, to ensure functional utility, not just fluency.
I'll challenge one assumption about data centers. Yes, proximity matters, but in some markets, the binding constraint is last-mile cost and reliability, not core compute. If broadband is unstable and expensive, people will default to mobile and intermittent use. So diffusion might accelerate faster with community networks, mesh Wi-Fi plus caching kiosks, than with a shiny regional cloud region. Also, headline adoption can mask productivity. Usage spikes don't equal value creation unless workflows change. We should measure composite outcomes like task cycle time, error reduction, and service satisfaction, not just DAUs.
Let's bring this to specific business cases. Could each of you point to sector deployments that illustrate how these diffusion levers turn into outcome improvements, ideally across varied markets?
In logistics, a port authority aligned with national digital strategy integrated AI scheduling with sensor-driven yard management. By moving from static timetables to AI-guided berth assignment with long context reasoning over weather and vessel data, they achieved mid-20% reduction in dwell time and better on-time performance. In financial services, a regional bank used AI-driven compliance explainers and document extraction to cut manual review cycles by nearly a third, freeing staff for higher-risk cases. These gains emerged only when policy coordination ensured data sharing and connectivity upgrades, so the AI had something to read and react to.
Rural health is a strong example. Clinics with solar microgrids and edge inference for triage assistance, quantized multilingual models with local medical glossaries, saw faster intake and fewer referral errors. Paired with asynchronous cloud sync when connectivity returns, outcomes improved with a drop in rework and patient wait times. Similarly, agriculture extension services deployed a Swahili assistant with WhatsApp SMS front ends, guiding planting schedules and pest management using local weather feeds. Farmers reported more consistent decisions and higher yield stability over seasons, which indicates behavioral adoption, not just trial curiosity.
SMEs benefit when the assistant fits their ledger and tax context. In one program, shop owners used a mobile-first AI to reconcile invoices against local VAT rules with a prompt template library. Features included photo-based receipt ingestion, bulk reconciliation, and instant compliance explainers. We watched task success go up week over week, and, this matters, trust grew when we supported local dialect mixed with English, plus offline-first caching so they could keep working during connectivity dips. The repeat usage pattern doubled after we introduced progressive previews that summarize the action before the full analysis lands.
In manufacturing, a hybrid neural symbolic plus RAG approach wrapped around maintenance manuals and sensor logs produced interpretable recommendations. The symbolic layer encoded safety constraints, while the LLM generated step-by-step procedures. Paired with a retrieval corpus, the system reduced process deviations and cut maintenance downtime substantially. Technically, this balanced parametric knowledge and retrieval and used stable latency budgets achieved via on-prem inference when compliance demanded localization. It's a case where architecture choices directly impact throughput and operator trust.
And to support those cases, the network and compute architecture used regional peering with local ISPs, CDNs caching the top K embeddings for frequently retrieved documents, and microbatches tuned for inference throughput. We also used policy-aware routing. If data must stay local, the request is serviced by an on-prem GPU or CPU cluster with the quantized model. Otherwise, the pattern is edge for pre-processing, cloud for heavy reasoning. Energy-wise, immersion cooling kept thermal headroom for burst loads. These architectural details kept P95 latency below 2 seconds, which, as mentioned, correlates strongly with engagement.
From a policy standpoint, these cases only scale when privacy and safety governance are understood by users. Health triage assistants must have clear fallbacks and disclaimers, and decision support should be auditable. Governments should create sandboxes for sector experiments, health, finance, education, where AI systems can be tested against harms and benefits. The report's emphasis on diffusion reminds us to measure inclusion, track low-resource language usage and outcomes, not just aggregate numbers. Otherwise, we claim progress while leaving many behind.
On education, building content in local languages requires microcurricula aligned to national standards. A bilingual tutor assistant can prompt students in their home language and assess in the instructional language, providing richer formative feedback. We used curriculum-aware prompt templates and domain-specific lexicons to avoid mistranslation of scientific terms. Evaluation included HLE-style adversarial questions to ensure reasoning. Classrooms reported higher engagement and fewer misunderstandings when the assistant respected code-switching norms.
Quick contrarian note. We could be underestimating the role of radio and community media as bridges. AI-generated scripts in local languages, delivered via radio or WhatsApp voice notes, can push knowledge without requiring personal device interactions. That's diffusion via media, not apps. If the index only captures device telemetry, we're missing a channel that still reaches millions and, frankly, could be the fastest way to scale education and public service explainers.
That's fair. Our diffusion index is strongest on personal device activity, and while we adjust for desktop versus mobile, broadcast media isn't captured. A next iteration could triangulate with survey data on AI-mediated content consumption and partnerships with telecoms for aggregate SMS USSD interactions. Methodologically, we'd need privacy-preserving aggregation and robust sampling, but it would broaden the lens on use beyond logged app events.
Let's pivot to language and business contexts. How do companies practically overcome low-resource language gaps without waiting for perfect corpora or national internet upgrades?
Practically, you combine transfer learning and synthetic data with robust evaluation. Take a multilingual base model, add language-specific adapters via LoRa, low-rank matrices inserted into attention and MLP layers, train with community corpora and back translation, and constrain generation with lexicon prompts. Pair that with RAG over domain documents, so factuality doesn't rely solely on parametric memory. Tokenization matters. Build a sentence-piece vocabulary that respects morphology, reducing fragmentation. And at runtime, dynamic prompting can embed bilingual glossaries to stabilize terminology.
Also, embrace speech. Low-resource languages often have rich oral content. A small speech corpus plus forced alignment can power ASR and TTS. We calibrate prosody and tone for comprehension, and we include code-switching tolerance because users mix languages naturally. Training with mixed language segments improves robustness. Beyond models, invest in community data stewardship councils, so content creation is ethical and inclusive, that builds trust and sustainability.
In product, we don't wait for perfection. We ship minimum viable fluency with guardrails. The assistant knows when it's uncertain and asks clarifying questions in the user's language. Templates are localized, not just translated. A tax explainer references the actual forms people use. We make UI text editable by local partners, like teachers or accountants. This co-design approach produces utility fast and reduces error-caused mistrust.
A governance nuance. For synthetic data, policies should require disclosure and quality checks. Otherwise, we risk encoding biases. We can adopt nutrition labels for models and corpora, detailing language coverage, data sources, and evaluation results. This supports informed adoption by institutions and regulators.
Let's address infrastructure concentration, 86% in the US and China. What are viable paths to expand capacity outside the North without repeating mistakes of centralized control? 3 paths. 1. Modular data centers near renewables, solar, wind, hydro, with battery and, where feasible, green hydrogen for firming. 2. Regional inference fabrics, smaller clusters with strong peering and caching, which deliver good enough latency without mega-regions. 3. Microgrids for public institutions, schools, clinics, with local compute nodes. We also push standardized footprints, liquid cooling, PUE targets, and containerized GPU racks so capacity can be dropped into emerging markets faster. Compute sovereignty grows when you balance energy, network, and law. Add in hybrid deployment patterns inside countries. Local inference gateways to meet data residency, while cloud handles heavy tasks when policies allow. This incremental build-out lets ministries and enterprises adopt without waiting for a hyperscale region. We've done pilots where city halls run quantized models on modest servers for document workflows. When they need long context reasoning, they burst to the cloud via a controlled gateway. This respects law and accelerates usage.
I'll caution against over-romanticizing local capacity. Energy and maintenance skills can be bottlenecks. A realistic path is thin local, thick edge. Keep small inference caches local, but rely on regional edge clusters managed by experienced providers. Meanwhile, invest heavily in workforce development. Operators, network engineers, security analysts. Otherwise, shiny racks become liabilities. Diffusion is as much about people as hardware.
On investment strategy, public-private partnerships can de-risk the early stages. Governments set clear data policies and skills programs and invite providers to build regional edges with transparent pricing and uptime commitments. Industry clusters, agriculture tech, health tech, fintech, anchor demand. Diffusion is faster when anchor tenants exist. Incremental ROI builds as sectors show measurable gains. Compliance cycle reductions, logistics turnaround improvements, patient triage accuracy. These create political and economic momentum.
We've referenced electricity repeatedly. Can you connect energy access to adoption in a way that's actionable for both policymakers and CTOs?
Energy access is foundational. Without reliable electricity, connectivity collapses and devices die. Policies should target universal access with priority tiers, public services first, then small businesses. Using blended finance where appropriate, measure diffusion gains as energy access expands. Track AI usage in electrified zones versus non-electrified. This makes the case that power investments directly improve digital inclusion.
From the CTO side, design systems that degrade gracefully. battery-backed local nodes, offline-first client apps, and sync strategies. Factor energy into SLAs with regional providers. Energy-aware scheduling. Defer non-urgent batch inference to off-peak periods. Consider waste heat reuse and power purchase agreements tied to renewables. This turns energy constraints into design requirements, not afterthoughts.
Technically, you can reduce energy per inference with quantization, 4-bit, spec decoding, predict tokens with a small model and verify with a larger one, and caching. Retrieval offloads heavy reasoning to indexed corpora, avoiding expensive token generation. These optimizations allow more sessions per kilowatt hour, which is a practical diffusion metric in constrained markets.
Let's circle back to adoption measurement. Does headline usage equate to productivity? And how should enterprises and governments measure real diffusion outcomes?
Usage is necessary but insufficient. Our index tracks adoption, but we urge complementary metrics: task completion rates, error reduction, cycle time changes, and satisfaction scores. We can instrument task-specific telemetry, document extraction accuracy, lesson plan completion, triage decisions to trace from usage to outcomes. Methodological transparency matters, so we publish evaluation rubrics and sampling strategies. Future work includes integrating sector benchmarks into the diffusion index.
Enterprises should resist vanity metrics. Momentum comes from operational KPIs, fewer process deviations, faster service turnarounds, and higher operator confidence. Also, watch substitution versus augmentation. Are workers offloading rote tasks and gaining time for higher value work? Diffusion that improves worker experience sticks. Diffusion that adds cognitive overhead fails.
In product analytics, we tie adoption to retained workflows. We score assistance on time to insight and rework rate. How often do users redo a task after AI assistance? These correlate with trust and habit formation. We run cohort analyses by language and bandwidth tier to ensure we're not masking gaps behind averages. This is how we course-correct feature design.
The report identified language as a new barrier. Countries with low resource languages adopt less, even when GDP and connectivity are similar. What near-term steps can business leaders take to mitigate this in the next 12 to 18 months?
Leaders should allocate budget to localization and community partnerships as first-class deliverables. Work with universities and media organizations to build domain corpora, finance, agriculture, health in local languages. Integrate bilingual support in customer channels. Set targets for language coverage in products and tie them to OKRs. Sector pilots with clear outcome metrics. Yield stability, compliance throughput, clinic triage accuracy. Create proof points that justify scaling. Technically, start with adapters and RAG. It's faster to ship functional assistance in local languages by binding domain retrieval and using adapters than by retraining giant bases. Deploy speech where literacy gaps exist. Build evaluation sets with community stakeholders. Even small-scale corpora quality beats quantity when curated. This compresses time to utility.
Policy can accelerate by funding open corpora and translation initiatives, plus stipend programs for creators producing public interest content in local languages. Include accessibility requirements in government procurements. Bidders must demonstrate language coverage and low bandwidth support. Diffusion becomes equitable when incentives align.
One nuance: tokenizers. Businesses forget this. If your tokenizer mangles the local language, your assistant will underperform. Invest in language-specific vocabularies. It's a relatively small engineering effort with disproportionate impact on model quality.
The frontier is narrowing, China trailing the US by less than 6 months, Israel within a year. Does this accelerate global diffusion or entrench concentration?
It accelerates capability diffusion because training techniques and evaluation practices spread rapidly. However, without infrastructure diversification, usage will still cluster. The index shows we need both builders and infrastructure to evolve. Otherwise, you get model parity but experience inequality due to latency, cost, or regulatory hurdles.
Infrastructure can catch up via regional edges and modular builds. If nations prioritize neutral internet exchanges, peering, and local energy projects, they can provide good enough latency for most workloads. Specialized training clusters may remain concentrated, but inference can and should be broadly distributed.
I'll add that concentration risk isn't only about compute, it's about supply chains, GPUs, firmware, container orchestration. Resiliency requires diversification and open tooling. Otherwise, geopolitical shocks become adoption shocks. Diffusion needs redundancy.
On the ground, redundancy is pragmatic. Hybrid routing, multiple ISPs, and failover plans. We rehearse outage drills so services continue with degraded functionality. This keeps public trust intact, which is vital for diffusion. Let's tackle the ethics of speed. AI is the fastest spreading technology in history. How do we avoid repeating the inequities of prior revolutions?
By embedding inclusion from the start, power, connectivity, skills, language, and measuring it, set equitable coverage goals and report on them. Build data protection and safety into deployments. Include community voices in design and support creators who enrich local corpora. Diffusion that ignores these will deepen divides, even if averages look good.
In product, we default to transparency. Explain sources, show confidence levels, and allow users to correct the assistant. Trust grows when users feel in control. We also avoid dark patterns that push usage without utility. A respectful assistant earns adoption and avoids harm.
The research community should prioritize underrepresented languages in benchmarks and funding. We should normalize papers that show simple but inclusive methods, tokenizer tuning, adapter training, and community corpora, alongside frontier models. Inclusivity is a research goal, not an afterthought.
As we approach the close, I want each of you to give a concise, actionable heuristic, a rule of thumb, for business or technology leaders navigating AI diffusion in the next 2 years.
Measure what matters. Combine adoption telemetry with task outcome metrics. Publish your evaluation criteria. Transparency earns trust and drives better decisions.
Latency is destiny. Hold P95 below 2 seconds and optimize token throughput with caching, quantization, and speculative decoding. Adoption follows performance.
Design for failure. Assume power and connectivity will break. Build offline-first workflows and legal-compliant hybrid routes. Resilience is the real feature.
Stack the basics. Invest in connectivity, skills, and localized content before fancy models. Industrial ROI compounds when foundations are solid.
Inclusion is policy. Set language coverage, safety standards, and data governance as requirements, not aspirations. Measure and enforce them.
Fit the workflow. Ship features that solve tasks now. Templates, explainers, and local dialect support. Trust grows when the assistant saves time today.
Watch the bottlenecks. GDP correlates, but payment rails, trust, and media matter. Experiment with mobile-first, offline, and community channels. Measure productivity, not just usage.
Proximity pays. Place inference near users, tighten peering, and design energy-efficient clusters. Better latency and reliability trigger engagement.
Tune the tokenizer. Language performance starts at the subword level. Pair adapters with RAG and community corpora. Small steps lift big outcomes.
To borrow from Edison, innovation is 1% inspiration and 99% perspiration. But diffusion adds a third ingredient, coordination. The AI Diffusion Report reminds us that builders, infrastructure, and users must evolve together. The fastest diffusion in history will be judged not by the models we build, but by who benefits, in which languages, and across which sectors. Thanks to our panel for the rigor and energy, and to you for listening. Until next time, keep balancing accessibility with intellectual honesty and build for outcomes, not headlines. Before we sign off, let's stitch the threads together. Today we map the 3 forces of diffusion: frontier builders, infrastructure builders, and users, and the 5 building blocks: electricity, data centers, internet, skills, language. We unpacked the indices: frontier, infrastructure, diffusion, and highlighted that AI is the fastest spreading general-purpose technology ever, with 1.2 billion users in under 3 years. Yet adoption is roughly double in the global north versus the global south. Leaders like Singapore and the UAE prove coordinated policy, skills, and connectivity can outpace frontier invention, while frontier performance is converging. China is within 6 months of the US. even as compute remains concentrated, 86% in the US and China, which makes proximity, peering, and energy-smart regional designs the practical levers for equitable diffusion.
For the business lens, the end-to-end playbook is clear. Treat AI infrastructure like ports. Lay connectivity and skills first, then anchor demand with sector pilots in logistics, finance, manufacturing, and health. Measure outcomes, cycle time cuts, error reductions, service reliability, not just usage. Set OKRs for language coverage and latency budgets, and use public-private partnerships to de-risk regional edges and skill pipelines. Diffusion compounds when the basics are stacked.
Technically, the key innovations we covered: RAG to externalize facts, LoRa adapters for rapid multilingual tuning, tokenizer customization to respect morphology, plus inference optimizations like quantization, speculative decoding, caching, and regional peering, translate directly into lower latency, higher trust, and lower energy per inference. The heuristic stands: hold P95 under 2 seconds, and design for failure with offline-first capabilities, and adoption follows.
Infrastructure-wise, modular data centers near renewables, immersion cooling, microgrids for public institutions, and policy-aware routing create compute sovereignty without megascale. Edge caches, IX peering, and regional inference fabrics smooth tail latency and keep engagement up. Proximity pays when paired with resilient energy and networks.
Governance and inclusion thread through it all. Fund local corpora, require transparent model nutrition labels, build sandboxes for sector pilots, and set language access as a procurement requirement. Balance data localization with cross-border inference to protect citizens while keeping innovation alive. Diffusion is equitable only when power, connectivity, skills, and language co-evolve.
And the contrarian reminder: don't overlook mobile-first offline assistance, USSD SMS flows, and community media, radio scripts, WhatsApp voice notes, as parallel diffusion channels. Measure productivity, not vanity usage. As Drucker said, what gets measured gets managed. So manage for outcomes.
Final highlights and takeaways. Frontier is narrowing, infrastructure must diversify, and language is the new structural gatekeeper. Key innovations to act on now: adapters plus RAG for rapid localization, tokenizer tuning, regional peering and caching, energy-efficient modular data centers, offline-first product design with progressive streaming. Near-term moves for leaders: set latency and language OKRs, build community corpora, invest in skills and microgrids, launch sector pilots with outcome metrics, and publish evaluation rubrics for trust. Diffusion is the coordination of builders, infrastructure, and users, and the next 2 years will decide whether AI's benefits spread broadly or concentrate narrowly. Thanks to our panel and to you for joining us. Keep building for proximity, inclusion, and measurable outcomes, and we'll see you on the next AI on AI. Enjoyed the discussion? Pass it along to someone wrestling with these challenges so they can accelerate too.